Hello and welcome to this new tutorial. In the previous tutorial we defined the architecture of our discriminator, so now we are one step left to get our second brain. Before that we need to make the forward function. We're going to make a new forward function, this time for the brain of the discriminator. This is going to be almost the same as the forward function we made for the generator, but there is going to be a slight difference, a slight trick not to forget to apply. We'll see that in this tutorial. Alright, so let's define a new function that we're going to call again forward. There is no danger to call it again forward. And this forward function is going to take two arguments, the same as before, self to refer to the object, and because we're going to use the meta module main to forward propagate the signal inside the neural network. And the second argument is going to be the input of the discriminator neural network. So keep in mind and keep it well understood, the input of the neural network of the discriminator is an image that is going to be one of the images created by the generator. Alright, so an input of 3 dimensions corresponding to the 3 channels. And let's also keep in mind that the output of the discriminator, and therefore of this forward function, is a discriminating number that is going to be a value between 0 and 1, and that will do the discrimination according to which a number close to 0 will reject the image and a number close to 1 will accept the image. So let's recap. The process is actually very easy to understand for the discriminator. The discriminator takes as input an image created by the generator, and for this image it will decide if it wants to accept it or reject it. And to make that decision, it will return the output, that is the discriminating number between 0 and 1. And if this output is close to 0, it will reject it. And if it is close to 1, it will accept it. So that's why, in some way, the discriminator is discriminating the creations of the generator. And so now we perfectly understand the name of what we're implementing, the generative adversarial networks. Well, this name is perfectly chosen because the discriminator is an adversary of the generator. It is like some kind of an adversary judge, judging the creations of the generator, judging whether they should be accepted or not. Alright, so now that we understand clearly what's the input and what's the output, let's go inside the function and let's define what we want it to do. So the first thing that we need to do is get the output. Alright, the output that is returned by the main meta module of our object, which is referred by self. So I'm taking my object self, and then I'm taking the main meta module, inside which, of course, I have to input, well, the input. Alright, the input image, an image created by the generator. So that returns the output, and in the end, of course, we must not forget to return the output, because that's exactly the role of the forward function. Not only it propagates the signal inside the neural network, but also, and mostly, it returns the output, that is the discriminating value between 0 and 1. But here comes the little trick that we must not forget here. If you have guessed about it, congratulations. It's actually slightly technical. This trick has to do with the result of the convolutions. If we have a better look at the architecture of the neural network of the discriminator, we see that it's actually a sequence of convolutions. But if you remember how a CNN works, that is a convolutional neural network composed of several convolutions, that is exactly what we have right here. Well, at the end of a CNN, we need to flatten the result of all the convolutions. That is the result of what we get after applying the last convolution. So the trick, well, actually, the thing that we have to do now is exactly this. Flattening, we have to flatten the result of the convolutions. And we need to do this so that all the elements of the output are along one same dimension. And by the way, this dimension corresponds to the dimension of the batch size. So now the question is, how do we flatten, using PyTorch, an output that is the result of several convolutions? Well, it's actually very easy. Once you know the trick, we have to add here a dot, and then we simply need to use the view function to which we input -1. This means nothing else than we want to flatten the result of the convolutions that at the end are in 2D, 2 dimensions, into one same dimension along one same flattened vector. Alright? And that's done. We are done with the forward function. So congratulations, you have made the architecture of the second brain of the deep convolutional GANs. So that's quite a big deal. And now, since the architecture is made, we can create as many brains of discriminator as we want, and we'll create one in the next tutorial. Until then, enjoy computer vision!